The meeting of Energy and Climate will come to order. I note a quorum is present. Welcome, everyone. Today we're going to begin a series of informational hearings. Next week, we are going to hear from PCA on their report on greenhouse gas emissions. We will then have a follow-up on a deep dive into the electric grid and how it operates. We'll hear about efficiency at a following hearing and storage. After this series of hearings, we will have a chance for citizens to come and comment, critique what they've heard, and offer suggestions or whatever. So we will allow ample time for that. After these hearings, we will take up bills, but we won't take up any bills before we've had this series of hearings. And so with that, since we have a packed agenda today, I would like to welcome Dr. Mark Seeley from the University of Minnesota. And as Representative Garofalo said, you will recognize his voice, and he will tell you why. He will emcee today and then introduce the other professors, faculty from the U who are going to be presenting to us. With that, welcome, Dr. Seeley.
Thank you, Jean. It's a pleasure to be with you today. Those of you that don't know me, I'm a 40-year University of Minnesota faculty member who retired last year, although I'm still very active. I also have been working with University of Minnesota Extension during that time, so I've probably been to your neighborhood at one time or another because I've covered all 87 counties in our state. I'm also author of this piece of work, which is our comprehensive state climate history, and represents 8 years of my life. The Minnesota Weather Almanac, everything of any significance that's happened to us as a state from the standpoint of weather and climate is documented in this book. Back to our purpose today, we're very grateful for this opportunity. We first and foremost want to thank Jean Wagenius for inviting us here today. A little bit about who we are and our perspective in participating in events like this. We are all scientists and educators. So both today and in the Thursday session, you'll be hearing from your land-grant university in that context. Our currency is knowledge. We've all dedicated our lives to science and the advancement of knowledge. That's more or less how we measure our achievements. We are also your neighbors and fellow citizens. And that, believe me, is a strong motivation for participating in events like this. Because when we have knowledge that we feel is important, knowledge that we feel could be more pragmatically applied to make our lives in Minnesota better, we are motivated to participate in things like this. The University of Minnesota has been in existence longer than the state of Minnesota. We have had many functions over time. The Institute on the Environment was initiated many years ago. Jessica Hellman is the current director, who you'll be meeting along with other colleagues on Thursday of this week. University of Minnesota Extension, which not too many years ago had its centennial in the state of Minnesota, has been serving Minnesota communities for well over a century. And then we've also been very active in the Minnesota Climate Adaptation Partnership, which is a joint statewide committee that pulls together people from all over the state to talk about climate change in our state, educate, and look at applications of things that have been done in a very pragmatic way. Practitioners, it's really a practitioners conference. We've been trying to nurture that community for several years. In fact, since 2007, we've been trying to nurture that committee here the state of Minnesota. Our task is going to be to talk about climate science and climate change, talk about what's going on in the state of Minnesota, and also talk about what science shows as terms of strategic strategies to deal with it. Now, one real important point for context that's, I think, critical for us all to remember for both today and Thursday is, yes, there's geographic disparity in what climate change is doing, in both the signals, the measured signals of climate change and its consequences. We all acknowledge that, and it's highly visible to anybody that's got a pair of eyes. But right here in Minnesota, right in the heart of the North American continent, we occupy a piece of American real estate that is seeing some of the most profound changes of anywhere in the country. And this is well documented by all the science. And as legislators, we need to pay attention to what's happening in our own backyard. And what's happening in our own backyard is a pace of climate change that is unprecedented. Yes, indeed, climate change has occurred for 4.5 billion years, as long as planet Earth has existed. But the pace of change year by year, decade by decade that we are living through right now is totally unprecedented. And given that we manage our natural resources and our infrastructure based heavily on our climate knowledge, our knowledge of climate and climate behavior and climate extremes, it's really, really important to pay attention to these changes. So that's about all I'm going to say from the onset. Again, our gratitude for inviting us today. We hope to be here today as brokers of knowledge and understanding about what the climate is doing in our state, and also about what the future holds and how we might strategize to cope with it. We have two experts today that will be dominantly presenting the material to you. We'll lead off with Dr. Tracy Twine from the Department of Soil, Water, and Climate. Her more detailed biographical information is in the handout in front of you. And we'll follow Dr. Twine with a brief Q&A and then move to Dr. Peter Reich from the Forest Resources, who's both a McKnight and a Regents Professor at the University of Minnesota, very much widely respected across the world, who's also going to present after Tracy is done. So with that, I'd like to turn it over to Dr. Tracy Twine for her presentation, and then we'll move along respecting our time constraints this morning. Again, thank you very much.
Dr. Twine, just before you start, I would like for those of us who are watching on television to know that the slides are posted on our website, on our committee website, House of Representatives, and just look at the Energy and Climate website, so folks can follow along with you. Dr. Twine.
Thanks, Mark. Thank you, Chair Wagenius and members of the committee, for giving me this opportunity to present to you today and answer your questions. As Mark said, Minnesota is a unique place. It's unique. We have many biomes. We have forests and prairies and croplands, some cities and humans, and it's unique because of our geographic location. We are located exactly halfway between the equator and the North Pole. And this means that the jet stream, this boundary between hot air to our south and cold air to our north, is directly above us. And it oscillates back and forth, bringing us cold air in winter and hot air in summer. And because of this location, we are sensitive to climate change. So today I will give you an overview of why we know this and how climate has been changing in Minnesota and what we might expect. We know that climate change is caused by humans, first of all, because of our fundamental physics. Second of all, we have a historical record. So if we look at the record of the global temperature, what we see as records began in 1850 is that we've had a drastic increase in global average temperature since about 1970. And that little red dot all the way to the right is 2018. And so 2018 is likely to be the fourth hottest year on record. We also understand how our climate is changing because of climate models. Climate models not only give us a forecast of what might happen in the future, but help us currently understand all of the ecosystems and processes that occur on planet Earth. So a climate model takes all these components of Earth, everything you see in the photograph on the left there, and parses it into systems. It takes our land, our oceans, our lakes, our atmosphere, our ice, our clouds, and it represents them as a system of forcings and responses, and then changing elements that we call variables that we can quantify, things like temperature, precipitation, clouds. Models perform billions of calculations over thousands of what we call grid cells across the Earth that you see there in the figure. So we partition Earth into all of these different grid cells. So they cover the Earth. There's thousands of them. They also extend up into different layers of the atmosphere, down into the ocean, and down into the soil in our land. At the limits of our knowledge of these equations, we put some numbers in that we call parameters. And so these are numbers that we can tweak and put in these models in order to give us correct answers. And these parameters can be tweaked for different situations. Climate models have a similar architecture as the weather models that forecast our weather over the next week. They're just run differently. There are about 40 of these global climate models from about 10 nations that are generally accepted. Usually large institutions like national labs are the ones who maintain these models. But thousands of scientists like myself and others use these models in our research to answer our scientific questions. We take these models, we test them, we break them, we fix them. Overall, then we improve them, the models get upgraded, and then they're available for everyone to use. In order to test these, we compare what comes out of these models with any observational database that we have available. So some of these come from satellites, satellite sensors that get a vision of our entire Earth from space. Measurements that are made at the Earth's surface, as you see in the lower figure, all those red dots, either on the land or from ocean buoys that are constantly making measurements. We use that to evaluate our models. Even data from aircraft. So I don't know if many people realize this, but all the airplanes that are flying in the sky are constantly measuring their environment, and we use that information. A second way we test our models is to look at how the models represent what we call emergent behaviors. So the upper right figure, if you look along the equator, you'll see the white clouds. That's the intertropical convergence zone. That's a location of where air meets at the equator and is lifted, and we have a lot of convective storms. These storms in the model don't arise from any particular calculation or equation, but from various complex processes that are simulated in the model, all come together. And in the lower right figure, the model is predicting the precipitation from these storms, so that we know that models are capturing these global scale processes. We have confidence in these models because, first, they use fundamental physics. Second, they're able to represent these emergent behaviors like the intertropical convergence zone I just showed you, or other phenomenon like El Nino. Because they're able to represent features of our climate past, like previous warm periods or previous cool periods after volcanic eruptions. So this figure here is showing you the change in temperature over the last century. And if you look at all those yellow wiggles, those are all the various model simulations. The black line is from observations, and then the red line would be the average of all of our models. So we take our output from all of our models and we average them. And you can see that the average of the models in the red line compares very well with the black line and captures the increase in global average temperature. If we don't put appropriate values of particles in the atmosphere from volcanic eruptions or the proper amount of greenhouse gases, our models don't represent reality that we see in this figure. Now, we can't exactly represent all the physics and chemistry and biology and humans in these models. We just have to basically guess at the limits of our knowledge, and that's where these parameters come in that we're constantly tweaking and testing. So this model shows how our models have performed in the past. The black line is observations, and then that gray is the envelope of what the models have produced. And so we've done a good job in the past, but then that is the variability amongst the models in the gray. And going into the future, you can see what our uncertainty is. And the orange captures our uncertainty and natural variability. It's the lowest. We have a pretty good understanding of how our Earth varies naturally. The next largest uncertainty is blue, and that is how the climate is going to respond to our forcings. And then finally in green, our largest uncertainty is human decisions and our human emissions, because really, we don't know exactly what our human emissions are going to be in the future. That's up to us to decide. And so what we do is we run our models with a variety of scenarios. If our emissions are this, this is what we might expect. If our emissions are this is what we might expect. And so that's why this envelope of green increases as we go into the future, because that's basically up to us. Our climate models have improved over time, and they're incorporating more complex processes. There are things that they still don't represent. Most of the models currently don't explicitly represent pastures and croplands, the human-managed ecosystems that cover 40% of our Earth's surface. We don't have cities in these models because they're just too small for that size of the grid cell in that figure of the Earth that I showed you. And so what we can do is take output from these global climate models and run them in our weather models over a smaller region of the Earth to fill in the details that we're lacking in the global climate models. So this top right figure is a representation of our best global climate model. And you can see all the little squares are on there are representing the size of the model grid cells. What you can see here is that each side of those model grid cells is about 54 miles across. So that's, to give you an example, the distance from Thief River Falls to Grand Forks. What we're having to do in this model is say, it's the same, we have the same value of each variable within that grid cell. So it's the same temperature, it's the same rainfall, it's the same wind, it's the same clouds over 54 miles. If you look down below, this gives you an idea of what our weather and regional climate models can produce. There's more detail in this example of Europe. You can see more details of the elevation here in Europe. The grid cells are smaller, there's a higher density. And in this case, they're about 19 miles on each side of the grid cell, which is like St. Louis Park to Maplewood. So again, we're assuming in these models that there's the same temperature and rain and wind from St. Louis Park to Maplewood. But that is the status of our modeling right now. So what we want to do is use these regional models to fill in the gaps of what we're lacking in our global models. And this is really kind of like comparing climate to weather. So climate is a statistic. It's an average of all of our weather. We're really looking at means versus extremes. If you think climate is your personality, then weather is your mood. It fluctuates. And you could also say climate is what you expect and weather is what you get. So, we expect January's in Minnesota to look like the figure on the left, snow-covered. But what we get is January of 2019 on the right. So we are affected by weather, not really climate. So we need to prepare for changes in our weather. And what climate change does is it induces a shift in both means and extremes. This distribution right here is giving you an indication of how climate will change this. So at the peak there, that's the mean. That's averaging all the weather. And climate change shifts that mean slightly to the right. But with this distribution, what happens is there's a substantial change in the extremes, the tail ends of this distribution. So we would get a small increase maybe in the mean, large changes, a lot less cold weather, a lot more hot weather. So what we need to do is prepare for what's going to happen in those tail ends. So we need regional models to downscale these global processes and fill in our details. Regional models do a better job than global climate models of simulating near surface temperature, precipitation, things that are relevant to us. This is one example of what a downscaled regional climate model looks like, where the colors here are showing you a change in precipitation and those lines are showing you changes in wind. Now, we don't just need to use these regional models to project what's going to happen in the future with climate change. We're using them today for a variety of experiments. And in this experiment, what my group has done is we've changed the land surface. We've grown a variety of grasses south of Minnesota for bioenergy with our question of what does that do to the atmosphere? And it shows, in this case, a little bit more rain up here in Minnesota. But you'll see it's splotchy. There's greens and there's blues. A global climate model might give you just a smear of green, and you don't know how that varies across our state that is very heterogeneous with many biomes. And so this model output looks more like the radar observations that we see, where we see patches. And this is what's useful for us. I'm going to stop this section right here, and I can entertain some questions.
Members, questions will come through the chair. Are there questions for members at this time? We're going to have other times you can ask questions too.
Madam Chair, Professor Twine, and back on slide 8, there's the variability of models, which I think is from the IPCC. And with the report this past year that the IPCC put out showing that there was a large difference between 2 degrees warming versus 1.5 degree warming. I'm wondering if we have that information for Minnesota about what shaving off a 0.5 degree warming would mean for Minnesota.
Chair Guinness, members of the committee, thanks for that question. That is an excellent question, and we don't know quite yet. I think that is where these downscaled models can help us give an indication, because that report is very recent, and that is looking at the global average temperature. Obviously, our question for Minnesota is, what does that mean for us? One thing is that what I'll show in the next block of slides is that Minnesota is warming at a faster rate than the average. So I think we could expect to see more warming here for that.
Representative Acombe? Did you have?
I was just indicating that Representative Vaughn had a question. Thank you.
Representative Swedzinski?
Thank you, Chair Wagenius. Just also looking at page 8 on the slides, if you could switch over to that one for everyone. Kind of looking at the no model is perfect portion. So let's say you had your way, everything, so that you would stop that increase.
Okay.
So on your model, every single increase has got it increasing. What would have to happen so that it wouldn't?
So thank you for the question, Chair.
In your opinion.
Madam Chair and members of the committee. In my opinion, what would have to happen to bring this increase down is what you're asking?
Or just stop it?
To stop the increase. Well, what the scientists are saying is that it's going to be a long time until we can reverse this. Carbon dioxide gets into our atmosphere and it stays for a long time. And so we already have some changes in the system. So the sooner we can reduce our greenhouse gas emissions, the sooner that will come down, but it's going to take a long time to bring that down. Right now, what we're doing is trying to minimize that increase.
Representative Swedzinski?
Thank you, Madam Chair. Just, from a CO, you say CO2 stays in the atmosphere for a long time. Let's say today we stopped emitting CO2, other than people breathing potentially. Like, how long would that CO2 take to work its way out of the climate?
Thanks for the question, members of the committee. Carbon dioxide it's a difficult question because any one molecule can stay in the atmosphere from 20 to 200 years. And so if we stopped all of our emissions today, and so they were all in zero, we would still see some warming. And it's difficult to know for how long because of some feedbacks that are in process. So our sea ice is a very good way to cool the planet because it's highly reflective, and that has already dropped. So that would take thousands of years to build back up. So I think we would still see warming even if we cut our emissions to zero. Now, how the way the processes work and the warming works is the more you can reduce those emissions, the better off we'll be, because these projections are showing that it's going to be much more detrimental to have a warming of 2 degrees and 1.5 degrees. So that just means that the more we can reduce that warming, the better off the globe is going to be. But there is still going to be some changes in the pipeline. If that's a great theoretical question, if we dropped our emissions to zero, that would be great.
Dr. Seeley, would you like to?
I just want to amplify a point Dr. Twine mentioned and I mentioned in the introduction. It can't be overstated that for every incremental change we look at in the global record or the global model, what all the research shows is that translates to a very highly amplified change in our Minnesota backyard. That can't be overstated. So when we talk about these small perturbations relative to the global climate record, those translate to big perturbations in Minnesota.
Thank you. We'll go to Representative Hornstein.
Thank you, Madam Chair, and thank you so much, all of you, for coming. It seems that we've had, several studies that have been released just in the last few months, and they all seem to indicate that the rate of climate change is accelerating, perhaps accelerating faster than even scientists had previously, predicted. And so I guess I wanted you to comment a little on some of those studies and what does this rate of acceleration mean?
Thank you, Madam Chair, members of the committee. There are feedbacks in the system that are nonlinear, and so that is things like our greenhouse gas increase and our loss of sea ice and other changes in the earth, how clouds are distributed. That amplify those small changes. And so what has happened is at the global scale, we have not decreased our emissions, and that's why you continue to see this increasing rate. So at the highest level emission scenario on this figure here, you'll see that is extremely nonlinear and the most rapid rate of warming. Yep. I'll show you some trends in the next block of slides here in Minnesota on how that is not linear and how the trend of our past 100 years versus our last 20 years is rapidly increasing. Yep.
Thank you for that.
Thank you.
Representative Halverson.
For anybody on the panel, I'm wondering if you might be able to comment on past impacts that humans have had on our environment and ways that humans have been able to mitigate or change trends through policy or other kinds of actions. So we can have a better understanding of the way that policy maybe impacts our direction.
Thank you, Madam Chair and members of the committee. One great example is for ozone, stratospheric ozone, and the Montreal Protocol. So that's an example that a lot of climate scientists look to as something that we can bring together globally. So chlorofluorocarbons were emitted into the atmosphere. They were determined to cause a destruction of ozone in the stratosphere, and that led to the ozone hole, and that led to more ultraviolet light reaching the surface, damaging animals, plants, and humans. And so there was a global policy to eliminate the use of those. And then the ozone hole is improving. that was not an easy problem. This is even less of an easy problem because carbon dioxide is not just simply like chlorofluorocarbons. It's everywhere. We rely on it for our lifestyle. And so I think the positive thing that we can draw from the example of the Montreal Protocol is that we have a lot of options that you will hopefully hear from in the near future. Great examples here in Minnesota of just how we don't need to emit so much carbon dioxide, and there are a lot of options to have the same kind of results as we did decreasing chlorofluorocarbons by having other forms of energy.
Thank you. Representative Bierman.
Thank you, Madam Chair. Thank you, Professor Twine. So on the model we're looking at there on the emissions that you discussed, best case scenario on emissions, we're going straight up till 2080. And I believe you mentioned that cropland isn't factored into any emissions at all. How about livestock?
Oh, Madam Chair and members of the committee, thank you for that question. That is a great question, and I will clarify that these models will use the best estimates of emissions from those sectors, so from cities, livestock, all kinds of agriculture. Scientists have a very good knowledge of exactly how many emissions are coming from those sectors and going into our atmosphere. What we don't represent in the model is what's then at the land surface. So right now, all the croplands and pastures just look like grasses in the models. So we're doing an excellent job of capturing the atmosphere's response to these emissions. What people like myself are interested in is what does that mean at the land surface? Here in Minnesota, what does it mean for our forests versus our prairies? And what we want, what these models are being developed and improved to do is to incorporate that management of the land surface so that we can see what happens to water as it flows along the surface in those particular biomes.
Dr. Twine, why don't you continue with your presentation?
Okay, thank you, Madam Chair. Oops. Okay. So in this next block, I will talk about what we know about climate change in Minnesota and where we think we might be going. In that one previous slide, I mentioned 2018 could likely be the fourth hottest year on record at the global scale. What does that really mean for Minnesota? Well, winter is warming in Minnesota 13 times faster than summer. So really our warming comes from winters. This table here is breaking up this trend in warming between winter and summer. And if you look along the bottom, the summer trends, on the left, we have an average change per decade since records began in 1895. And on the right is our more recent change since 1970. So there is not an increasing trend in warming in summer in Minnesota. And in fact, that trend is not super large. Winter, however, is having a significant increase in its warming rate. And in fact, Minnesota is one of the top 3 fastest warming states in the nation. And Minneapolis and Mankato are 2 of the 3 fastest warming cities in the nation. Across the state, we're not seeing temperatures as low as they used to be. So this figure on the left is just for Minneapolis-St. Paul. You can go to Climate Central and choose any city, and it will show you similar increasing trends in our state. From 1970 to the present, you'll see this is the lowest temperature recorded each year. And so it varies depending on what kind of weather we have from year to year, but there's a substantial increasing trend in our lowest temperatures. On the right is temperature by decade in Grand Rapids, temperatures that are minus 35 degrees Fahrenheit or lower. And so you can see it kind of held steady with having maybe 10 of those days each year until the past 20 years, where it's really hard to find days below minus 35 in Grand Rapids. This figure here, if I can explain to you, is looking at the length and magnitude of the 10-degree Fahrenheit season in Duluth. So Where it's shaded is showing you an average over the period from 1959 to 1978. So it's basically showing you the length of the season and also just how much cooler than 10 degrees Fahrenheit it is. So that second week in January, going up to that 5 there, is basically saying it's typically 5 degrees Fahrenheit, 5 degrees less than the 10-degree Fahrenheit. So if we go to our next averaging period of 1979 to 1998, you can see a substantial change here, both in the length of the season of weather below 10 degrees Fahrenheit and also in that magnitude. So by it reaching 2 in that second week of January, now we expect that week to be about 8 degrees Fahrenheit in Duluth. So it's warming. And it's not having as long of a season as before. If we move to our next averaging period of 1999 to 2018, you don't see anything because it's gone. What this means is we just don't expect temperature to be below 10 degrees Fahrenheit in Duluth anymore. So over the year, Minnesota is warming. The map on the left is showing you the annual average, and you can see that there's a warming trend, and it's warming more in the north than it is in the south. The middle figure is showing you our trend in winter low temperatures, how significantly they have increased. And again, the winter lows have increased more to the north and in the south. And then on the right is our trend in summer high temperatures. Our summer low temperatures have also increased, but our high temperatures of the day don't show a warming very much. It's very small in the north and a very small cooling in the south. So what we currently are seeing is we're not seeing a trend in the heat events here in Minnesota. However, this is something to keep an eye on because our models are projecting that that is something that's going to change. So whereas our other trends are going to be continuing, this is something we're not seeing yet, but the models project that we might have 5 to 10 more days per year above 95 degrees Fahrenheit by mid-century in that southern half of our state. Overall, Minnesota is getting warmer and wetter everywhere and in all seasons. So on the right, this is broken up by region of the state, and this is our average change per decade. So rainfall and snowfall total are increasing everywhere. And on the left, it's broken up by season. So you can just see how the trend over the last basically 100 years is increasing. The largest increase is rain in the spring. We're also increasing our precipitation in winter. But keep in mind that as we warm, more snow is going to fall as rain. So we need to be prepared for that. Heavy rainfall is increasing everywhere across the upper Midwest. And what this figure is showing you is the frequency of these strong storms. And what you'll see starting in the 1980s and then into the 1990s, particularly in the 2000s, is that in that light blue and dark blue, that our storms that give us 2 inches per storm or 3 inches per storm are dramatically increasing in frequency. We're getting more heavier rainfall events. And just this past year, in 2018, we broke our state record of annual precipitation. In not just one location, but in the same year, we broke it in 2 locations. 2 locations exceeded our all-time record of total precipitation. So our record is now 60 inches of precipitation. That's an average rainfall in Miami, Florida. We're getting much, much wetter. And at one of those locations, the record was pushed over the edge by an 8-inch rainstorm. So one super storm. The other location, it was really made up of a series of heavy rainstorms, just one after the other. And so what the global models are projecting, they're projecting more of this precipitation, but they're projecting more of this to run off the surface, which leads to lower soil moisture. So that means that more water is becoming less available to plants. And this increase in our extreme events is expected to continue. On the left, this is a global climate model projection, and if you pick out Minnesota in those figures, you'll see that the global models project increases in seasonal precipitation in fall, winter, and spring, and a decrease in summer, a drying of summer. And on the right is more projections of what will happen to the extreme precipitation. So in our Midwest region, you'll see the top is a lower emission scenario and the bottom is a higher emission, whether it's mid-century or late century. We're expected to see increases in this extreme precipitation. Keep in mind here, if you look at Minnesota on the left, that you really just see one single green color, so maybe a 25% increase across the state of Minnesota in precipitation. But we know how rain falls across the state. It's not going to be even like that. So that is just one more reason why these weather models are useful for us, to downscale that 25% increase in precipitation and ask, what does that mean in the sectors of our state? What does that mean in our various biomes? So this was a figure that my group created by downscaling global climate model projections over the state. You can see that it is not just a smear of green of 25% increase. So this is a percent change in June rainfall from our average from 1980 to 2000, and then looking towards the end of the century. And so you'll see a large increase, but some variability there. So we're interested in seeing what this might mean at not just the state level, but at the county level. So this is just one realization of a model. What we plan to do is do this for many more global climate models. When we average them all together, we sort of see all those yellow wiggles that average to that one line to give us a more robust understanding of what might happen in the state. And then same projections are showing a change in August rainfall towards the end of the century, where now it's hardly increasing anywhere. These models are projecting a drying out of summer, and my colleagues will talk about some possible impacts for that. Again, more work of this is, these are hot off the presses. They'll be averaged to give us more robust understanding of what might happen. Looking at temperature, this is just for February, looking at projected high temperatures and low temperatures towards the end of the century. And you see winter temperatures that are near freezing in the high and the low. So on the left, the high temperature projections are about 5 degrees above what our current averages are in February. And the low temperatures are like 18 to 20 degrees higher than what they are now. And so what used to always be completely below freezing in February, you now see they're really hovering around the freezing mark. So I'm concerned when people talk about less snow, that will be safer. For a while, if we're hovering around freezing and we have freeze-thaw, we're going to have some hazardous conditions. So these are just some examples of things to keep an eye on for the future. And I thank you for your time and can answer questions, Chair.
Questions from members? Oh, Representative Purcell.
Thank you, Madam Chair. Yeah, I may have missed this, but northern Minnesota is my home, and we haven't had a big snow up there for a long time. 8-10 inches was the last one in many years. We haven't been anywhere close to our 6-foot average for decades. What's the phenomenon associated with that? We talk about more precipitation, but talking about rainfall up our way anyway.
Yes, thank you, Madam Chair and members of the committee for the question. That is global warming. So there are always natural variability in the system that's happening, that's helping to bring us our El Nino winter of this year. So part of this warm winter is from the El Nino phenomenon, which is completely natural. But that continued warming that you see up north with the decreases in the snow that you used to see is from anthropogenic global warming. So it is warm temperatures. We're not getting, and that affects the jet stream that moves the storms through our region. And so we're not getting the type of storms anymore, and if they come, they don't have the moisture and the processes to drop that amount of snow.
If I may, just to follow up, so I'm just trying to put the two and two together. We've got more precipitation but less snow. Is there a rationale for the less snow as precipitation?
Thank you for the question. Yes, so the snow is created up aloft in the atmosphere. And in fact, even in summer with our thunderstorms we get on a hot, super hot day, there's snow and ice that are up aloft like that and just melt as they reach the surface. And so what's happening is it's still cold here. You're still below freezing up in northern Minnesota. It's still below freezing up in the atmosphere. But the factors that come together, bringing moisture from the south of us and the systems that set up as air flows over the Rocky Mountains are changing. So we will still get heavy snow events once in a while, but that average of not seeing them as frequently is from an overall warming from global climate change.
Thank you.
Mm-hmm.
I don't see other questions. Are we ready for Dr. Reich?
Thank you, Chair Wagenius. Can you hear me? Well, I'm going to take this opportunity, for which I'm glad to have the chance to share with you and your committee about the future impacts of climate change on Minnesota. I'm going to be a transition from Professor Twine's talk today to the talks you'll hear on Thursday, because she talked about how our climate is changing. I'm going to ask what do those changes mean for us here in Minnesota, and then you'll hear more details about that on Thursday. It's very important to begin by pointing out that climate change and its impacts are not going to be due just to the climate and weather being a little warmer on average by 1 or 2 degrees. Instead, the impacts will largely be through these extreme weather events. If you look here on this slide, you can see the 2017 billion-dollar weather and climate disasters, according to NOAA, for the U.S., due to floods, hurricanes, fires, and the like. And although we can't attribute any one of these to climate change, we do know that because the climate system has a lot more energy, we're likely to see more intense events like this, and this intensity of events has been increasing and is expected to continue to increase, so the supercharging of our weather system is going to lead to larger events which have greater impacts. And so for Minnesota, the extreme and severe weather events that are going to matter and do matter are things like heat waves, droughts, heavy rainfalls and floods, windstorms, and wildfires. And I'll spend a few minutes talking about each of these. As you saw from Professor Twine, we already see a big increase in the rain falling in our heaviest events. Since the 1950s, we see a 42% increase in the rain that falls in heavy downpours, meaning the 1 in 100 biggest storms every year have 42% more rain in them. Not surprisingly, if you have more rain, you're going to have more floods, especially if you have more rain in these heavy events. The green triangles show the places where in the last century we've had an increase in floods. The arrow points to Minnesota. We can see we've had a big increase in floods. Not surprising if more of our rain falls more intensely in fewer events. And again, as Professor Twine pointed out, this increase we've already seen in precipitation that's falling in our heaviest event is going to continue to increase, meaning by later this century we'll have doubled the size of the average heavy rainfall. So that's quite extreme, and that's something that will have impacts across the state. Now, despite the increase in general we've seen in precipitation, and the fact that we haven't seen an increase in summer temperatures so far, we will see a big increase in the number of days above 95 Fahrenheit projected by mid-century. So we're going to see our climate get wetter and warmer, but also more variable, such that despite a generally wetter climate in the future, our summers, especially late summers and falls, are going to be drier by as early as the 2030s. So the average may not change much, but because more of the rain falls in the winter and spring, or precipitation falls in winter and spring, less in late summer, and because warmer, drier conditions in late summer mean that soils and plants lose water faster, you need more rain simply to keep up with that. Any farmer or gardener knows in a hot, dry week, if you don't water your garden or you don't get rain, plants and soils dry out faster. And this global map here shows everywhere that's brown, soil water will be less than the 1990s by the 2030s in late summer from July through October. And you can see pretty much most of the continental United States is going to be drier in late summer. So wet springs, wet winters, dry late summers. If our summers and falls are drier and hotter, it's not surprising that wildfire potential would increase. On the two maps here, the left is summer, the right is fall. Brown and red show the largest increases in wildfire potential. Pretty much the eastern 3/4 of the country is going to have increased wildfire potential. Again, not surprisingly, actual numbers of fires and the intensity and size of them track wildfire potential fairly well. And so this is going to lead to more fires over time as well. Now, we talked about these various different kinds of events, floods, high rainfalls, heat waves, wildfires. Mark Seeley made this slide about 10 years ago because he was so impressed with what he called a 2007 climate aberration, where in August, 24 counties were federally designated drought disaster areas because of lack of rain. They're shown by the red X's there. 2 weeks later, because of heavy rains, 7 counties in the southeast part of the state were federal flood disasters. So maybe on average we're okay with our rain at the whole state, but part of the state was in deep drought and part of it was flooded. He called this an aberration, and yet just 5 years later, and this map looks a little bit different, the red and yellow counties here are again federal drought disaster areas, but the counties with the red crosses on them were FEMA flood disaster assistances at the same time. And this is the first time that any specific county was simultaneously eligible for drought and flood assistance. So we're getting more and more extreme weather. You might have droughts, you might have floods, they might come in succession, and this is expected to increase more in the future. Now, what does this mean? What are the impacts on the state? Now, we have a very diverse state. We have big cities, we have small towns, we have rural areas, and there's people living in all of those areas. We also, of course, have our beloved lakes and rivers that are scattered throughout the state. And we use our lands for agriculture, for forestry, for industry, and many other things. Now, in this slide, I'm trying to emphasize the complexity of what's going to happen to the state. On the left, we show what I'm calling the elements of climate and weather. And these are just in alphabetical order. Things like droughts, heat waves, heavy rainfalls, pollution from carbon emissions, overall warmth, wildfires, windstorms. And on the right, all the, what I'm calling sectors of our state activities: agriculture, biodiversity, cities, forests, health, industry, lakes and rivers, and recreation. And these climate elements each influence not just one, but many of these different sectors of society. And in fact, if I showed all the real arrows that occur, it would just be a big black smudge, because there's so many ways each of these elements influence each of these sectors. So there's a lot of complex impacts that are going to happen now and in the future. I'm going to spend a couple of slides for each of several of these sectors to give an overview of what you're going to see on Thursday. Now, for agriculture, if you have lots of rain in the spring, farmers have a hard time getting out in their fields and working their fields, and that's a big problem for them. But once the fields are planted, if we have really heavy rains later in the spring, or in midsummer, or when we want to go out and harvest, that's also a big problem. So our heavy rainfalls, whenever they occur, are going to be a problem for agriculture. Yet at the same time, well, not necessarily literally the same time, but in one year to the next, we might see heat and drought that has negative impacts on our agriculture. There's some photos here of corn and soybeans, our two main crops. Both of them are sensitive to high temperatures. Corn is shown on the left, soybean on the right. As your maximum temperatures increase, for every degree increase, there's a decrease in corn yield. So heat waves are also not good for agriculture. I'm next going to move to cities and towns. I'm going to start with this set of pictures here that shows on the left flooding in northwest Minnesota, and on the right, the 2012 flood in Duluth. Not surprisingly, major flooding of urban infrastructure causes all sorts of economic damages. And so when having more of these floods is not good for our cities and towns. But in addition to heavy rain, winds also are a big issue. You can see the two bottom left photos show wind damage to structures and to trees. But we've also had an increase to date in hailstorms. And actually in one of the committees here, maybe 6 years ago, someone from the state insurance business came and talked. Household insurance, even by then, had increased more than doubled, I think, in a decade, far faster than the rate of inflation because of damages to homes, many of them due to hail damage. And we don't really know whether hail damage will continue to increase, but something like hail that we don't necessarily think of as a major climate change factor has already been a big impact economically in our state through its damage to homes. I'm going to turn to forests now, and you heard from Lee Freilich on Thursday about forests. Here we're asking what happens as we globally and regionally turn up the heat in our atmosphere. I'm showing an iconic picture of a northern forest in northern Minnesota there. The things that will affect the forest in the future are the direct temperature effects. A longer growing season might be good for their growth, but high temperatures in midsummer might be bad for their growth. We also have the effects of climate change related drought. Just like that might be bad for agriculture, it's also bad for forests. And we have indirects of climate change, increases in windstorms and wildfires, but also increases in insect and pathogens that have a big impact on forests, and those are increasing because of climate change as well, because many of these insects formerly were restricted from northern Minnesota because of the really severe cold winters that we're not getting anymore. Just a picture of a blowdown following the July 4th, 1999 windstorm, and a picture of some of the landscape in northern Minnesota following the 2007 wildfires. So for forests, we know they're going to change, but how they'll change really depends on how our weather and climate changes. If the future is drier but warmer, we may get something that looks like that lower left picture of an oak savanna. That assumes that the bur oaks and other plant species can get there and thrive in those environments, which isn't a guarantee. If it's wetter as well as warmer, maybe we'll get a forest like the one in the bottom right picture, which is a classic oak maple forest. But again, this would require those trees either thriving if they're already there or arriving and thriving in the landscape that currently don't dominate. And if that doesn't happen, and we have invasive species such as buckthorn and other plants moving further north, we may get a scrub or shrubland for 50 or 100 years, which is neither environmentally or economically beneficial to us. So we know the forest will change, but exactly how isn't clear. I'm going to spend a minute talking about human health because sometimes people think that human health isn't a climate change issue, but that's not true. And you'll hear from Dr. Shurapaneni on Thursday about human health effects. Extreme heat is a big driver. Professor Twine didn't mention it, I don't think, but our cities are, and she works on this, our cities are warming much faster than the rest of the landscape. So extreme heat events in cities is really problematic for people who are vulnerable to heat wave events, but also for people who work outside in the heat. So there's lots of issues with extreme heat that will come on, maybe not in a major way in the next few years, but by mid-century and beyond. There's also the spread of infectious diseases, and I'm showing Lyme disease as an example here. If you look at the three maps from the late 1990s just to 2010, so only about a decade, the deeper and darker the blue, the greater the incidence of Lyme disease, and you can see how it's spread and increased across the state. There's many reasons for this, but in part it's because, again, the ticks that carry Lyme disease are also climate sensitive, and they're spreading north faster than we would have anticipated 20 years ago because of climate change. Air quality is an issue. Smog, allergens, and wildfire smoke all impact people. When we burn fossil fuels, smog is created that has impacts for people with asthma and other problems. There's more allergens. And wildfire smoke, not only from our own fires, but from fires as far away as British Columbia, actually negatively impact our air quality and have health impacts right here. And lastly, although we might think of our recreation as just for fun, if we lose our classic recreational opportunities, these actually will have negative impacts on physical and mental health. So it's not just that we won't get to enjoy our lakes and snow anymore, this will actually have real impacts on our health. The last thing I'm going to mention is lakes and rivers, which actually I don't think anyone is going to touch on Thursday, which is maybe an oversight, and you'll maybe hear from someone later this year about this, because there are already and will be really big impacts on lakes and rivers. The upper left is a photo of the St. Croix River in flood stage. Not surprisingly, with the increase in our super heavy rain events, lakes and rivers, streams and rivers fill up faster and flood more often and at higher levels. That's, again, a big problem environmentally and economically. Temperature also matters for lakes and rivers. As our average temperatures are increasing, we're getting more algal blooms, and this is occurring in our largest lakes to our smallest ponds and other waterways in between. Algal blooms have all sorts of nasty toxins in them, which create problems for anything that lives in the water, whether it's a plant or animal, like the fish shown dead in the bottom right. But also if people or our pets go in or near water when algal blooms occur, those toxins actually are a threat to our health as well. The last example I'm giving for lakes and rivers is our winter ice. Professor Twine mentioned we're warming winter 13 times faster than summer. And an iconic presence in Minnesota historically was our solid ice all winter long. That's not occurring very much anywhere in most winters. And this has impacts on a variety of things we do on the ice for recreation or for tourism industry and the like. So I've kind of given you a whirlwind tour of the way in which impacts might occur. I've touched upon only a small number of these. You'll hear about more of them on Thursday. And although they're very serious, we shouldn't, hopefully you are not going to walk away from here thinking everything is doom and gloom, because that won't get us anywhere. There are many challenges and they're serious, but as you'll hear on Thursday, we should think of these as opportunities to both adapt and mitigate. We can slow and eventually stop climate change, and we need to adapt to it as we slow it and stop it. And there's many, many ways we can go about doing that. And you'll hear many of them actually save us money rather than cost us money, and some cost money, but it might be well worth spending that money. So I hope you're looking forward to hearing more details about a lot of this on Thursday. And if we have time, I'm happy to entertain questions.
Thank you, Madam Chair. Professor Reich, I'm interested in your crop yield decline slide on temperatures.
Sure.
It seems like this is projecting the impact simply of the temperature change on crop yields. We've also heard in the presentations today projections about higher rainfall, about lower soil moisture, about drought, about extreme weather events. I'm wondering if there are projections that combine the different effects and their impact on crop yields in the future.
That's an excellent question. There are such projections, and all of those things do matter. And some things you didn't mention, which also matter, is that farmers are really clever and they're constantly adapting by changing the cultivars or changing the crops, changing when they're planting, all those kinds of things to try to adapt to the changing climate. So all of the things you mentioned will impact agriculture. What we don't know is how much the climate will change in all of those ways, where and when. And so our uncertainty about how our climate is changing and when and where brings more uncertainty than what will happen to the crops and their yields. Because if we knew how climate was changing, we could do a reasonably good job of projecting those changes. So some years we'll see great harvests because we have abundant rain and it's not too hot and it's not too hot at the wrong time. Other years we may get droughts that really knock back knock back yield. And it may be that our yield is on average unchanged, but maybe we have more years with super great yields and harvests and more years with bad harvests. We really don't know exactly where we're going with that. I don't know if you have a further thought.
Representative Bierman.
Thank you, Madam Chair. Professor, I'm just following up on the crop side of it. What about livestock and invasive species and the effects of those as far as human health and livestock health, and are we already seeing that?
Again, a great question. With a warming climate, it seems that many invasive species, whether they're weeds or diseases, with longer growing seasons, their populations expand faster and they can geographically spread faster and become more problematic. That seems to be the case for agriculture, for livestock, and for humans. Again, we don't know exactly where we're going with that, but that is for certain problems that is really happening fast. And I think you'll hear more about that on Thursday.
Representative Swazinski.
Thank you, Madam Chair. Just a general question. It was brought up earlier, Representative, is it Braham? Behrman? Sorry. I have one of those names no one can ever say, so I'm working on it. So, although I do appreciate Representative earlier that I said my name correctly, so I really do appreciate that. But just talking from an agriculturist perspective, I haven't seen myself, any change in yield. I would say it probably more of an increase in the past few years, but just kind of moving, I think, if we kind of come from the standpoint of, okay, whether you agree or not, something's changing or not, like from a policy standpoint, what it was brought up about animal agriculture, it was brought up about cattle, potentially, and it was stated earlier by Madam Twine, even if we quit emitting CO2 100%, we'd still see an increase in temperature. We'd still see rain events not change. Like what is the what's the policy that we're going to ultimately? I know that folks have talked a little bit about we need to do 100% fossil free and a goal to change that and move ourselves in that direction. But it doesn't sound potentially that actually would make a difference. We would still see an increase.
Well, it would make a big difference because as Professor Seeley pointed out, incrementally, if you increase carbon emissions a little bit, that amplifies, we get a bigger impact on the climate. And so if we can cut back our emissions, not just in Minnesota, but globally, that will help. So I think that it's not hopeless by any means. It just means it's serious. Getting back to your first point, we may be lucky that in terms of agriculture, that so far with rising CO2 and abundant rains and mildly warmer temperatures, that yields have been increasing. And that might continue for 5, 10, 15, 20 years. We don't know. But the projections are that the climate will become less hospitable for agriculture as it continues to warm and as summers get drier. And if springs become flashier in terms of rainfall, if a lot of that rain falls in these super deluges, that may have negative impacts depending on when they occur relative to when planting was done and things of that nature. So I think we may have the luxury of a little bit of time for agriculture to figure out how to adapt to the changes, but that doesn't mean they're not coming. So,
Dr. Seeley.
I just wanted to amplify this discussion a little bit with a thank you, kudos to the Minnesota legislature for your support and forethought many years ago in funding the invasive species research initiatives at the University of Minnesota. This is very important not only to the management of our natural resources, but to the management of our agriculture, both the crop sector and the livestock sector. Climate change is a big player in this, in that we don't necessarily know all that's ahead of us with respect to invasive species, but we have many working examples. For example, the influx of Asian soybean rust in our country was just a number of years ago due to a hurricane landfall when the spores came into the southeastern U.S. As the climate has since changed, the overwintering ability of that organism has migrated north, so that one day it is not out of the realm of possibility that we will see the disease Asian soybean rust in Minnesota in some prolific way that we will have to treat, because it will be able to overwinter in the United States much closer to our border. That's just a small example of all the organisms that we might not be able to anticipate that may come into play as a result of climate change and affect the management of our agriculture and our natural resources. So this is very much justified that your land-grant university is looking into this and trying to develop a better research base for us to anticipate what might happen to us in the future.
Just a follow-up on that particular soybean. Is this does it overwinter on buckthorn?
Yes.
No.
No, kudzu. Kudzu is its primary host.
But I could jump in, Madam Chair.
Could, Dr.
The
Reich.
soybean aphid overwinters on buckthorn, and it's an obligate host. So as buckthorn, an invasive tree, moves further north, in part probably because of climate change, it's also spreading the soybean aphid, which is becoming a major problem for soybean growers as well. And so there's the combination of an invasive plant carrying a disease for agriculture. So it's, I don't know, a double or triple whammy there that's climate change is having helping it move along.
Is there research then on buckthorn specifically?
Yes, there's a variety of research, not only on buckthorn, but on soybean aphid. Some of it funded through the LCCMR, through these state centers on invasive species, that's trying to figure out the extent of the problem and what can be done about it. So again, the legislature is trying to stay, and I think helping us stay ahead of the curve on that, or at least trying to keep up with the curve.
Secretary Twine.
Thank you, Madam Chair. I'd also just to add, so thank you to the legislature, because the invasive species group is working on, in addition to these two examples, a variety of pests that are already being seen in other parts of the country, such as the brown marmorated stink bug, which is a huge pest to the east. It's a nuisance to people, and it's also a damaging economic pest to crops. And so that is seen right now here in the Twin Cities. They'll start in our warmest areas of the state, and then move to where they can survive. And again, yes, with our warmer winters, that's especially disturbing, because typically these populations would die. They would have to migrate back the following spring. Now, if they can overwinter and stay, it could be an explosion of population. So what we're doing is working with these climate projections, feeding them to entomologists at the university to put into their models so that we can be prepared for a variety of species that might have an impact on us.
I brought up the buckthorn because I saw a map from the Invasive Species Institute folks that showed counties that had a little bit of buckthorn that were also agricultural counties. And the notion was, would it be worthwhile or practical to eliminate the buckthorn in those counties? And so I was just asking about that.
Well, my opinion is yes, and we're actually working on with many other people on trying to figure out how to make that happen.
Representative Hornstein's next.
Thank you, Madam Chair. This would really be for perhaps anyone on the panel. In addition to the conversation we're having about agriculture and crops, I'm wondering if you have done some research about urban and regional land use patterns and changes in terms of how they're impacting climate, our choices, transportation choices, how we design our cities and our regions.
Dr. Seeley.
If I can take a crack at that, thank you. Interacting with the Minnesota Climate Adaptation Partnership Committee for the last decade, we've had a number of city engineers and a number from MnDOT as well as other state agencies present some very pragmatic approaches to dealing with this. For example, in play now in the design of Minnesota roads and highways is a whole different approach to culvert design, where we have to steer waterways because we're now using NOAA Atlas 14 for that purpose, which has dramatically increased the recurrence intervals or the magnitude of rainfalls and their recurrence intervals in the state. There's a big debate, in fact, coming up at the City Engineers Conference February 1st that's going to deal with that, because many of the engineers feel that the climate is changing so rapidly in Minnesota that the NOAA Atlas 14 calculations need to be revisited every complete decade, just like the new climate normals are published every complete decade, because the pace of change is so remarkable. So if you want to design for the 50-year storm or the 25-year storm, but that number is changing decade by decade, you need to be aware of that. So there's lots of things happening around the state that we see pattern tile drainage in play in many of our agricultural sectors, so that farmers can get in their fields that much earlier in the spring when we have these particularly wet. We even have experimentation in southwestern Minnesota on controlled pattern tile drainage, so that you can actually find ways to hold water in the root zone during periods of drought and dismiss water when you need to dismiss surplus water. So we've got all kinds of activities going on at the county level and local unit of government level. Lots of reasons to learn from each other, which is why we host the Practitioners Conference every year in Minnesota to talk about such things.
Do you have a follow-up?
Thank you. No.
Representative Halverson.
Thank you, Madam Chair, and thanks to the panel for this discussion. I'm actually new to this committee, so this is really interesting and frightening information. One of the things I wanted to lift up, and I think Dr. Seeley has been emphasizing this as well, but when I heard Dr. Reich say that 15 years from now, our agricultural, our ability to grow crops in Minnesota could look vastly different. I thought to myself, well, that's 7 legislative sessions, basically. I mean, that's tomorrow in terms of public policy. And for as fast as we tend to move at the legislature. And so I feel that the sense of urgency is pretty stark for our state in terms of, if we want to be the state that feeds the world, if we want to be the state where people come from around the world to swim in our lakes and paddle our rivers and those kinds of things, if we want to be the state where people, the state of hockey, we have a lot of work to do fairly quickly. So I just wanted to emphasize that that's what I was hearing, and would look for any comments that you had.
I echo your comments. I think there's lots of things that are changing that we value that are going to either change or go away entirely, and some of them are economic, some of them are cultural, some are both, maybe both, most are both, and so we have to figure out how to hold on to those things in a way that makes sense, and we also have to start to recognize which of those are more vulnerable and which we can adapt to better. For instance, agriculture, despite the risk, there's a lot of ability of the agriculture industry to adapt because you plant something every year. Foresters, we can't do that. Trees take a long time to grow in Minnesota. Urban infrastructure, highways, those things you don't change every year what you're doing. So I think although we focus on agriculture, agriculture may have more capacity to adapt than many other sectors in the state. Not that it's necessarily less at risk, but that there's lots of other things that we do with a 50-year time horizon or a 20-year time horizon. And as Mark just pointed out, you know, we need to be thinking about the change that's going to come in that period and not be planning for 2030 with the climate of 1970.
Follow up? Just to follow up quickly, I think that your notes about agriculture are really interesting. My question is, and I think that the question for policymakers are we willing to adapt? Because one of the things I think that, particularly at the federal level, agriculture policy tends to do is support the status quo. This is what we're comfortable. This is what our infrastructure is built for. This is what farmers are doing, and we want to continue to support their success. And so I don't know that our policies necessarily are keeping up with the notion that we might have to adapt.
No, and I think that's why Chair Eugenius has you all here, is to learn about what's going on so that you can, because it's not, we can't, the three of us can't make those changes, but you and the other legislatures around the country and the federal legislature can start to make those changes to make us slightly more secure for the future climate.
Representative Stevenson.
Thank you, Madam Chair. And Madam Chair, I guess we've had a good discussion about some of the plants and animals that might be coming to Minnesota as invasive species in the future, but we haven't talked as much about what plants and animals might be leaving Minnesota as our climate warms. And I note that in particular, I've been showing with some of my colleagues a very heartbreaking chart I saw yesterday that the Audubon Society prepared, showing that by 2080, the summer habitat of the common loon does not include Minnesota. And as heartbreaking as to imagine a Minnesota without loon calls in the summer, I'm wondering what other plants and animals will we expect to be leaving Minnesota over the course of the next few decades as a result of climate change?
It's a great but harrowing question. Because northern Minnesota is the southern fringe of what's called the boreal forest and is very different biotically than the temperate forest or the prairie grasslands that occupied the southwest part of the state when European settlers arrived, that southern fringe of the boreal zone is much more vulnerable than the temperate forest or the prairie, and is particularly vulnerable because it's at the southern warmer edge. And so many of the elements of that kind of ecosystem are threatened in Minnesota, whether we're talking about moose, whether we're talking about balsam fir and white spruce and black spruce. The species who are adapted to cold winters and cool summers, a whole raft of them are going to become less abundant, and some of them are going to disappear entirely from our state. And for some of those, that's almost guaranteed at this point because we're not going to slow and stop climate change fast enough. I wish I could guarantee that we're going to have loons here in 100 years, or balsam fir, but I can't do that yet.
Do you want to follow up on that? I think that's okay. Representative Christensen.
Madam Chair, thank you. This is an open question. I'm wondering if we're going to be discussing economic impacts, public health impacts, just social impacts as a result of climate change. Perhaps that's coming Thursday more. I'm wondering if we can elaborate on that a little bit more.
It is, you're going to hear from a number of people on Thursday about, well, you're going to hear from one medical doctor about human health effects, and you're going to hear from a couple of people about the ways in which we can re-engineer our business and policy along the lines you're talking about for those social and economic impacts. So just stay tuned for Thursday.
There, posted online now is our agenda for Thursday, which will, there is a whole list. Okay, posted online now is an agenda for Thursday, which will include, I think, everything you have asked about. But it's a much longer agenda. I think we will be going faster. And so have your questions ready for Thursday. I don't see further questions. I just want a great appreciation for organizing and coming and educating us. This is sobering. But I expect that I had students visit me a couple of weeks ago. They were high school students. They want us to move so much faster in preventing climate change and in adapting. And I think you've given us a lot of reason to listen to those younger folks even more than we've been doing. Again, thank you so much for coming, and I see no further questions, and the meeting is adjourned.